Hello and welcome back to problems on orbital mechanics for engineering students. The last video was problem 1.2 and now we're moving on to problem 1.3. However, problem 1.3 specifies three vectors and claims they are where they say they are in the picture, but actually when you put into MATLAB, vector A, B, and C, they all turn out to be on the same plane. And in fact, the answer is given to you in the question. C, A, B is in fact equal to C, which is, the normal of C is actually 11.58. So the question is not correct, and we'll just move on to 1.4. 1.4 is asking us to prove some identities again using the bac-cab rule. What it wants us to do is it wants us to show that unit vector t cross multiplied with unit vector normal is equal to unit vector b. So that's the tangent, that's the normal, and that's, well, the base or something 90 degrees to it. It's a, right hand rule. There's three vectors all laid out 90 degrees to each other. Very exciting, really. And it wants us to show that this is true. That this is true, and this is true. So that's the unit vector. Each unit vector results in the other one, basically the one that's not there. So tangent cross multiplied by the normal equals the base cross multiplied by tangent equals the normal, and the normal cross multiplied by the base equals tangent. It's specifically asking for these two here, using the bac-cab rule. So what I decided to do was simply put this here. So we have unit vector base cross multiplied by unit vector n, unit vector b equals unit vector normal. So we've just inserted that into there and given us that. Now we can use the bac-cab rule to rearrange this. That will be rearranged to make unit n times unit b dot, unit b minus unit b times unit b dot unit n equals unit n. So two vectors dot, a vector dotted with dot product with itself is actually equal to 1, and a unit vector or vector dot producted with something at 90 degrees to itself will be equal to 0. So that means un equals to un. So this question isn't really telling us very much, but that's that. 1.4.